Well, hello. Today I will this sort kind of video explain quadratic functions and how we can factor in each form. So let's start showing you what need to do. First, I will open my obsidian ball where I have the things I'm studying right now. Here. Here is. Well, factoring. First, what factoring is, you might be wondering. Factoring is just, as we know for the minimum multiple between numbers, a way to see similar patterns between numbers and make them easier to work with. Think, for example, factoring quadratics with a leading coefficient 1. Basically, you have, for example, this form x squared plus ax plus b. What you do once you have this form is think in a number that if you multiply that number times other number, you get b, and the sum of that number gives you the coefficient of a. This of here is just an abstraction. But before we can work with abstraction, we need to think in the pattern of x squared minus x minus 6. So let's factorize minus 6. Minus 6 is actually factorizable in minus 3 times 2. And we know that the sum of such numbers will give you minus 1. So we can actually break minus x in minus 3 and, plus 2. But remember, use the variable, multiply both by the variable, or it will be equal. So we can rewrite in this form x minus 3 times x plus 2. And all of that happens because maybe this isn't easier to visualize right here. But if you go move this a little bit, we can work this out. X squared minus 3x plus 2x minus 6. Sorry, minus 3 times 2 is actually the same of here, and in an easier way to visualize it, this downside. And what's interesting about this form, difference of squares, is we actually know both roots of our quadratic equation. Now you can use this x minus 3 times x plus 2. Give me a moment. Lock. To grab the roots of this number. So we know the actual roots are 3 and minus 2. Let's use a green color. 3 minus 2. You may be wondering which the vertex is, because we don't know the vertex right now in this form. To know if the vertex open outwards and downwards, we care about the symbol here. As you can see, in this case, the symbol is positive. So our parabola, we're opening this direction that I am showing you. But we don't know the vertex. We don't have the vertex form, so we can use the standard form to figure out what the vertex is using this formula here. That's basically b divided by 2a minus 2 minus for the numbers ax squared plus bx plus c. Computing for these numbers, we have minus 1, 2 times 1, that's equals to 2 times 1, here 1, minus 1/2. So this will be here approximately. Well, I'm back reviewing this. I make a little mistake. We here see a minus x, right? Basically, minus x it's minus 1 times x. And we see the vertex formula. We don't see the minus 1 here, isn't it? And here is my mistake. Minus, minus. Well, now the negative symbols can just cancel out, and we have a 1/2. 1/2. Would we know actually this value for vertex, but isn't it enough to build? Nothing. So we go down here and start making the y coordinate for vertex come to life. So we have 1/2 square minus 1/2 minus 6. This is the same as say 1 square divided 2 square. This equals to 4 over 1 minus 1/2 minus 6. You see this here in equivalent, so we can convert this to sort kind of equivalent expression. And the more quicker way to do is just multiply this by this. Sorry, multiply this by this, then multiply in a cross way. 4 times 2 equals to 8. 4 times 1 equals to 4, and 1 times 2 equals to 2. We solve this, we have 2x 1 4. Minus again 6 minus 6. Well, 1 4 minus 6, we multiply this entire number by our denominator, and we have 4 times 6 equals to 28. 4 minus 1 is equal to 23/4. Let's compute this. Divide by 4. 5,75. 5,75. So we right now knows the y coordinate and x coordinate of our numbers or vertex. Here is. We can start computing it. Well, I make some mistakes and I mark that mistakes with a question symbol. So I encourage you to pause this video and try to find what mistakes I made. Well, if you see this operation 1/4 minus 1/2, you know that this thing that you see actually doesn't make sense. 1/4 equals to 0,25 minus 0,5, and that's equals to minus 0.25. But I'm showing this to you guys because I want to be sure that when you are using this mechanical process in exams to basically try to gain more time, be careful. This doesn't make you resonate what you are doing a lot. If you are not paying attention, try to see the overall image, not just these lines. So this rewrite actually is 2 minus 4, okay? Because 1 times 2 equals 2, and 1 times 4 equals 4, and this is subtracting it. For 1/2 and minus 1/2 minus 6, it's basically equals to 6 entires times 4 denominator 24 minus 24 minus 1 divided by 4, this equals to minus 25 over 4. Computed it, 25 divided by 4 equals to 6,25. 6,25. So we will move in this direction. This is 6, and we want to find 6,25. So you have 6 here, minus 6, and 6,25 will be here, minus 6.25. And y coordinate will be here, like 1/2, approximately here. Oh well, guys, with this you can finally grab our form. And we got the results. So let's review just this a bit. We have this abstraction, and we use this abstraction to basically find factors we want to use. Like, we know that B can be break into M and N. M and M need to be equals to B. And M plus N should be equals to A. Once we got this factorial form, we use it. Minus 3x plus 2x plus minus 3 times 2. And if you make this calculation, you get the number we factorized earlier. And if you make these calculations more easier to do analytically or just for graphing, you use this difference of square forms that gave you the roots of x of our quadratic expression. And in the case you need the vertex for grab this, you can use the vertex form, the vertex equation. Gave you some kind of h, and you use this of below to find the key, basically replacing in the image of our function with 1/2, and we find that 1/2 here. And then with a vertex 2 points we can grab. Goodbye.